right away. So Carla, I'll let you start presenting and introduce yourself.
Hello, good morning, everyone. And thanks again for joining. Let me just get my screen shared here. Scott or Mike, can you see that all right?
Not yet. It's coming now. Yep. You're good.
Okay, great. Again, thanks everyone for joining. I'm Carla Jackson. I'm the Market Development Agronomist for Veritas. I am also in the Southwestern Ontario area where it's currently raining. So thankfully delayed some of the spring rush here. Today we will be talking about soil sampling resolutions, the insights from soil sampling to understand your field variability. The first couple slides might be review for some of you that took part last week, but the bulk of today's webinar will be going more in depth and show you what you can do with your soil sampling data. When you're considering precision ag, whether it's to get started or to make adjustments, there are a few questions to look at, mainly around what your decision-making process is. When it comes to answering these questions, such as what your equipment needs are, what input rate should you be going with, what are the environmental issues, do you follow your gut, or do you follow the trends online, or are you just following what's being said at the coffee shop? Or are you using the data to identify the problem? Are you having on-farm trials to figure out your input rate, or what should you be applying, or what seeding rate you should be going with? And are you measuring those results? You can use your own on-farm data to answer all 5 of these questions. As you get deeper into the precision ag, do I need different equipment, or do I already have what I need? Do I have the yield monitor? Do you have the planter? Is there grants out there that you could apply to help conduct these on-farm trials to get that data you need to figure out the right rates? Using traditional practices and straight rate applications, which you can see here by the gray line of a straight rate application to get an average yield of 200 bushels. And the blue line, which is your variable yield, you are only farming the field's average where the lines meet, and this has limited potential. We can use data to then look at the outlying areas of your field where we can apply variable rate. We can look at the higher yielding areas to look at if you're under applying your fertilizer and limiting your yield. And we can also look at the lower yielding areas where you may be over applying and you're just wasting money, and you could also be having a negative environmental impact. When using the proper application of data insights and technology to adjust your inputs and to achieve that higher yielding area, we can reduce the inputs in the lower yielding areas. You will then start to see how your input lines and your yield will start to line up because you're putting the fertilizer where it is needed. This is following your agronomist recommendations, as well as following the 4R nutrient stewardship. You're putting the nutrient where it's needed, and you are 4R compliant. Some are already collecting yield data. So when you use your yield map, you can see that the average yield for this field is 200 bushels. So similar to what you saw on this previous graph, the average yield for this field is 200 bushels. And if you're straight rate applying fertilizer, you're applying the same amount throughout this whole field, but you can easily see that the yield reached up to almost 385 bushels an acre in some areas, but it also went down to 16 bushels an acre. So you're applying the same amount across these areas, which they don't need it. Those are those outlying areas you want to target to start making the adjustments. Yield data is great to start collecting to see the areas that needed for improvement, but it needs to be combined with soil sampling to start making that data-driven decisions and to fully understand your field variability. You can take that yield map and choose the most representative of the fields. As you can see here in the middle, these are multiple years of yield data, and we chose the yield at the top that was most representative to what the field looked like, as you can see by the bare ground image on the left. We then created the zones based off of the yield, the bare ground, and also some elevation maps. We created the soil sampling zones. Those were then tested to capture that field's variability. Using as many data layers as possible to create the right zones and using the proven analysis is important to take your soil sampling resolution to the next level. Now, when you're getting into soil sampling or you've done it for a few years, you start to wonder, what resolution should I be sampling at? And the next couple slides will be going through the different methods and levels available. On the left is the yield data for a field, and you can see the polygons that were drawn to that yield. And on the right is a CEC layer from Soil Optics, which is very detailed look at the soil resolution from a sensor driven across the field. No zones were created. This is the actual data from the sensors. Then you look at the 25-acre grid, which is essentially bulk sampling that many are still doing today, as was shown in the poll today, that you can see that doing the bulk or the 25-acre grid and you compare it to the yield, you're not really capturing that yield variability that you can see on the left. Similar to the 10-acre grid and going down to the 5-acre grid, you still aren't really capturing that variability in that field as on the left. The 2.5-acre grid is one of the most common sampling resolutions across the industry today. And again, compared to the yields, it captures a little bit, but it's not accurately capturing what you're seeing in your actual yield year over year. You can even go down to the 1-acre grid, which is quite expensive and is probably the closest to the field variability in the grid method. Alternatively, if you want to get into zones or polygons, you can start at a 10-acre zone or polygon. It does classify the high and the low grounds, but again, it's not really showing you that variability in the yield. You can get to the 5-acre polygon as well as the 2.5-acre, where many are switching to after sampling for a few years. And it's the 2.5-acre polygon where you are starting to really see that variation in that yield. You're separating out those smaller bands of lower yield, and you're starting to capture those higher yielding areas over here. You can even get down to the 1-acre zone or polygon, which is probably the most accurate in the polygon method. But again, that is also very expensive. You can see the similarities between the sensor-based sampling between the 1-acre and the polygon, that they are quite similar in terms of the variation across the field. Depending on your fields, each sampling resolution will differ. You may have a field that is fairly flat, and you can do a 10-acre polygon, but you also may have a field similar to this where there's lots of knolls, a lot of variation, and you have to go to the 2.5-acre level. Now this example here, it is from Soil Optics, but I just want to make a note that there are other tools out there that are sensor based. They're similar, but they have different results. Now choosing the best resolution for your farm is important to be able to apply the fertilizer better. You want to work with your agronomist or your local retail to discuss what level is appropriate for you. But also being mindful of choosing the most economical method for your operation. That is very important. For some, depending on their end goal, the 5 acre, the 2.5 acre polygon has the best economical value for what you're trying to do. If it's looking to just increase your yield, or you're looking to find areas to reduce some of your input costs, the 5 acre, the 2.5 is the most common. When choosing your resolution, it is important to understand the difference in the method and what you are getting. For instance, zone sampling is one of the more common entry-level sampling techniques where there's good equipment and processes being used to create the zones. And each of these zones are sampled individually, but then they are all mixed. So all the zone ones are then mixed together into one sample bag. All the zone twos are sampled into one bag, all the zone threes, etc. Each zone of either the high ground or the low ground, they're all sampled individually, but then ultimately mixed into one bag. This helps save some money, but in the end, this ends up averaging out your soil results. This is still a good place to start for those that are not currently soil sampling, as this really starts to show your field variability. Now, another option, very similar to zone, but a little more detailed and more in depth, is the polygon sampling. So you can see here that these zones, similar to the zone sampling, that they're created to the field variation. The zones are then sampled individually, and they are put in individual bags sent to the lab to measure that variability as accurately as possible. And then on the right, the last one, the soil optics. This one has a similar amount of soil classifications as you can see to the zone. Zone sampling has about 5 different soil classifications, and soil optics has about 7. But if you look at the zoomed in area in the green box, each dot is, in theory, is a soil sampling bag. That is the data collected by the sensor. So this is why this sensor technology is so cool. The level of information is crazy, and it brings a lot of value to the farm, but it is also really hard to manage. It is impossible to manage the farm at this current state of the technology that we have to manage each of these individual dots at the farm level. Now this next part is going to be newer for those that were online. And this is where we start to go a little more in depth about what we can do with your soil sample, the insights that can be provided to soil sampling results. The soil analytics tool is available to provide the so what to soil sampling. Many growers do not sample due to the variety of reasons, but the most popular reason is that maybe the soil results don't help answer what they need to do on the farm, where the soil analytics tool can make your sampling data more actionable. You can take your soil test data and map out what the nutrient levels are in each polygon. This is essentially a map book. So you can see these soil sampling zones, and then each one was sampled separately, and then we are able to see what the nutrient levels are in each area. This is the potassium level. You can see how it varies throughout. And you can then pair it with your yield to see where that is impacting your yield. This is essentially a map book, and many of you may already receive this from the soil lab or your agronomist, but regardless of who you work with, a map book and a brief explanation of what the maps mean should be provided to you. It is important to note that when you're doing any analysis on your soil sampling, you should compare it to the similar year's yield. For example, this field, if it was sampled in the fall, you need to use that fall's yield to then do your analysis on. Or if you plan to sample now, Let's say you need to use last fall's, or in some people's cases, this winter's yield. You'll have to do the analysis on the most recent yield to when you're sampling. Now, once the field has been sampled, a deeper analysis by zone compared to the optimum yield can be done. Mike, if you'd be able to speak to this, but the potassium level on this farm.
Sure, Carla. A little later on, we'll take this field right through to entirety and show a little bit more on how we can get the value out of it. But out of the gate, here's some things we want to show for the next set of graphs that are going to pop up are how this field compares on fertility versus overall yield. So if we look up in this top corner here, where the yield map is, Carla, put your mouse in that really high yielding area in that section there. When we look at the soil test K level, you can see it is one of our lowest soil test levels and is actually below 100 in this field and is at a critical soil test value. Something we need to watch and something we need to build. When we look at the lower yielding area right directly next to it, you can see it has one of the highest potassium levels in the field in that zone there. So some interesting things to look at as we look at a historical practice of fertilizing. Those areas that are always high yielding always remove the most fertility, and with a straight rate application we've mined the soil and we may be leaving some bushels on the table. So those are the areas we need to look for out of the gate to improve our yields and spend a little bit of money to get that higher return. On the flip side, those really low yielding areas have always been low yielding and we've built fertility up. So right there, we can save some money. We can keep it in our pocket, or we can push that expenditure over to those other areas. And hopefully at the end of the day, spend the same amount of money on inputs, just do a lot better job farming the farm. A really neat thing I want to show, and we'll create some clarity later on in the graphs with this field, is the difference between that low potassium zone in that high yield environment and the zone second from the back, where we have some high potassium levels and yield is still high. The interesting thing there is that zone used to be wet. 3 or 4 years ago, we put a tile through and fixed the water issue, and now it begins to yield. So we have 2 high yielding zones in this field with completely different fertility underneath of them. Due to a management change and due to some, historical practices. The interesting part about this is now when I begin to push seed or nitrogen scripts on this farm, my Rex, typically we like to increase corn seeding rate and increase nitrogen rates out of the gate where yield's high. So when I do this on this farm, that zone at the back really performs. Fertility is high. I get the response. My script works. But that zone up near in the middle, when I do that, I tend to get lodging. There's not enough P and K in that zone to support a 300 plus bushel corn crop, and create some frustration. So, just going to a seed and nitrogen fertility script without understanding your soil and not knowing what fertility levels are underneath of it can often change the outcome of those other scripts, and we're not getting the full value potential that's there. So really interesting data you can look at, and without looking at this tool and using these types of graphs and charts, sometimes this information gets missed or we lose concept of it. And Carl will get into that a little bit on the next slide.
Yeah, as Mike pointed out, at the variation in potassium and its impact on the yield, you can look at this soil test result and you look at the potassium numbers, you would not have been able to understand that level of nutrients impact in those different zones in the field. And this is why many people have questions about what these numbers mean. When you look at that, it's like, great, okay, what's my optimum level? What should I be targeting? What is the actual nutrient that's limiting on my fields, and which one should I be focusing on to get the best or the greatest ROI that I can get for that field. Without the soil analytics, you won't be able to see that variation just from the soil test. The soil analytics does a statistical analysis on your soil results, and it can help answer what your optimum nutrient level should be.
Right, so when we look at the field and we overlay yield on top of each individual soil sample layer, we begin to be able to graph the results on charts that look like this. So not only do we get to see where yield is highest on the axis on the left, but we also see the soil test level across the axis on the bottom. So initially looking at that, we can begin to see, in relation to that graph Carla showed at the beginning, the opportunities where we can begin to cut back on fertility, where we're above that optimum level. And we can also show the areas in the field where we need to build soil to get some more yield potential. So when we look at this graph, we can see that the bicarb phosphorus optimum level should be about 28 part per million on this field. So moving forward, to look for that optimum yield potential, 28 is the number I want to focus on this farm. And it's the number I want to shoot to be my optimum. And I'm going to do that because that's what my data is telling me from my own field with my own yield monitor and accurate resolution from soil sample. When we move on to the potassium map, you can see it's not quite as nice of a curve, but that's because of that situation I was talking about on that last graph. So when we look at the far left side, that high tail is that really low producing area where that soil test level was around 100, slightly over or slightly under, right? That is still the highest testing area in the field, but for how long? If I keep going the way that farm's been farmed in the past, it might start to be at a critical level and start to rob, we might be more open to disease, things like that, lodging for sure. I want to focus myself more around those zones at the back where that 165 to 170 part per million is the right part per million for that farm. I need to build everything to the left up to that level, and I can begin to cut back and save everything on the right. So we can really start to see that if I can get that farm into that 171 area, that we're going to start to see some decent yield increases. The performance of my other prescriptions, if I choose to do that on the farm, will start to pay, and everything starts to build up holistically, and we start to really get some decent results from the Precision Ag program. When we look at the magnesium on this farm, for those of you that did look at that soil test sheet quickly, you could see pH was a major issue, calcium was low, magnesium was low, boron and some other things were low, and so the field needs a lot of work. And this graph exactly shows that. We need to increase magnesium on this farm to get a good result. The first place we're going to start, obviously, is with some dolomitic lime to get the calcium and magnesium and pH all in check. And then we'll begin to look at some K-Mag applications and some things like that to help top off the areas that don't get that lime application and then don't need that correction from pH.
Great, thanks, Mike. And to go along with those curves, the soil analytics tool also provide these maps which show each nutrient and where it's limiting. If it's too high, too low. This was a quick and easy way to see what the field needs. As Mike mentioned, the magnesium, it was limiting in this part of the field, and also the pH. So yes, we're gonna make a lime application, and then also boron, which is a micronutrient that has never really been sampled for on this farm. And it came back that it was limiting in over half of the fields. In a couple slides, I'm going to just show you kind of like the ROI of a case study on the impact boron had on a yield 2 years ago. These results ultimately can help answer the question of what nutrient do I fix first. The soil analytics tool helps focus on the most limiting nutrients, which then can be turned into variable rate fertilizer scripts. So you can see that we made a potassium script and we increased potassium in this higher yielding area to bring up that potassium. And we also reduced the amount of potassium in this back part of the field because that was already higher in potassium levels. And it was already yielding high. So we're trying to build up these other higher yielding areas. And this area, since it's historically always kind of a lower yielding area, we're not going to put as much there just because it's not going to see the benefit from that. And then also matching up with that magnesium map, we only applied a K-Meg blend in this part of the field. As you can see from the rest of the bare ground imagery, there was nothing applied to this area. So we're focusing a lot of our application in this area. Using the variable rate scripts, we are targeting the outliers of the field and changing the input amounts where they're needed. The data insights from your soil sampling results help target your fertilizer inputs to where it will be most utilized. As mentioned just a minute or so ago, the soil results showed that boron was lower on over half of the field. So I think 7 of the 18 or 14, whatever zones there was in this field, over half of it was limiting. So then decided to then create a on-off boron prescription. So you can see here, yellow was on and green is the off check blocks. The check blocks were strategically placed in the lower yielding area of the field, as well as the higher yielding area and the medium yielding area. The check blocks are done so we can do the analysis at the end of the year to see what its impact was on the yield. 1.25 pounds of boron was then applied pre-plant. And at the end of the year, we did the analysis and it showed that boron had an average increase of 13.7 bushels an acre. The low yielding areas here had about a 23 bushels an acre increase, and the higher yielding areas had about almost 6 bushels an acre increase, ultimately having an ROI of almost 200% and a net profit of $41 just by putting on boron on this field. Just wanted to know it's important that these scripts and analysis can be used in any application as long as there are capability of turning the product on and off, whether it's nitrogen, seed, fungicide, or any other nutrient. It can't be done if it's a blend. Is required. For instance, that we couldn't do this analysis if we just threw the boron in with the nitrogen. So we separated out those applications. Boron was applied, nitrogen followed, and then it was incorporated and then planted the following day. This trial is going to be repeated, I think, this year to see, and after a couple of years of trial to see if boron continued to have this great impact on yield. Eventually, boron will just be thrown in with the nitrogen from now on, knowing that it does pay and it does have an impact, and we won't have to do this analysis anymore. This was one of Mike's fields in the Blenheim area. So Mike, if you wanted to add anything else based on your experience from this trial.
Yeah, thanks, Carla. It was an interesting trial for us. We use this field as a test field quite often. Never ever measured for boron before in soil testing. We always just kind of did the basic with zinc and manganese approach, as many do across the province here and across North America for that matter, but was challenged, with these new soil insights tools we have to maybe look a little deeper and see if there's anything else negatively affecting yield. Lo and behold, boron did come up as one of the limiting factors. So we decided to do a test. What I really like about this test is it really uses all of the tools available in the marketplace, right? So we've used the yield monitor on the combine, and I'd like to add that's the only tool that my farm operation has is the yield monitor. We rely very heavily on our ag retailer to do the variable rate fertilizer applications, in this case, the variable rate spraying, and we use the analytics we get provided to us from Veritas to do the rest. With that being said, obviously a planter would be a nice upgrade for this field, but not something in the pocketbook right now. But with that, we were able to draw some decent zones, follow through with some soil sampling, then run the soil analytics tool on it to see the insights we got from that. We were then able to find a potential hidden hunger. We then put the prescription analysis tool in place, the script analysis, to run an ROI evaluation and then come to the end conclusion of, does that product make me money or not? Some really cool thoughts from the field. I mean, that if you look at those field averages down there, 150 bushel, that is the worst corn yield we've had in the operation in the last 10 years. That year was, as Carla mentioned, had some replanting and had some extreme drought on it. It was the worst cornfield we had that season. And the thought from my father in the combine was the boron really affected yield. You know, I think we killed the crop a little bit. It had a negative impact. And that probably would have been the decision we would have left the field with had we not done a deeper analysis and had the tools in place to do something like this. I was pleasantly surprised to see the positive result from that application. And as Carla mentioned, we're going to try it again this year, and we're going to spread it out on a couple other farms to see what we have. Again, this is a boron example, but the point of this slide is not to tell you all to go home and spray boron. The point of this slide is to show how the tool works together, all the tools work together to provide those deeper insights and stronger solutions to your operation. This could be any product. Every trip we have across a field today with a variable rate controller in our cab has the potential to be a test trip or a learning experience for the agronomist and for the customer. Using tools like this really allow us to dive into the data and find out what the real solution was. You can see that those blocks were placed very strategically so that we can learn from the high yielding and the low yielding areas in the field to really unearth and pull out some good results and be smarter. So whether it's a new foliar product, whether it's a new product that is being, presented in the marketplace, use this type of data and this type of solution to come to the real results and determine whether it's right for you and whether it does bring value to the operation. That's kind of the whole key behind this approach. And whether it's soil sampling and general fertility or any product that you want to try, this is the type of process that can be implemented today to help unearth that value and help you make smarter decisions.
Great, yeah, thank you. That's a good point, mentioning too that, yeah, only the yield monitors being used, and that you work closely with your ag retail to be able to apply these different tools. So in conclusion, every field has variability. And one thing I want to leave you guys with today is, how are you managing yours? Today's technology creates the opportunity to teach us something in every pass. We can become better in using the technology to learn faster. Field-specific data paired with the strong analytics, whether it's off your soil sampling or even just doing the analytics off of a nutrient application, this provides the SOA answers and the proof to help drive on-farm business decisions. Technology is here, and your next piece of equipment you buy will definitely have technology in it. By implementing these simple tools that we reviewed today, you can start collecting data and will help to take advantage of that new technology in year one rather than 3 years down the line. So you can, if you buy a planter next year, you already have that base data that you can start making those decisions on and utilizing that technology right away. So start collecting the data today, and you will need to farm with tomorrow. Thank you, and I guess we'll open it up to any questions.
Yeah, Carla, Mike, excuse me, Carla and Mike, thank you for taking us through that. I'm going to open up for the question and answer session in just a second. I see somebody has already typed a question in the chat feature, and if you could, I'm going to open up a question and answer bubble for you in just a second. If you could type your question in the question and answer section, that way we can clearly see that and make sure we address it. As Carla and Mike both said, we believe all your fields are different and they all need to be managed individually. Every grower knows their fields and understands that. And that's our value, or that's our understanding as we go out and interact with our clients. As we went through this today, we've demonstrated on a couple fields that each of your fields do have variability, and we've broken those fields down and showed how that variability looks. And then we talked about several ways to capture it through zone, grid, bulk, different soil sampling techniques. And then finally, Mike went into a bit of understanding how to get a positive ROI by capturing this variability and farming to this variability. So with that, I'm going to close the formal webinar portion, and we'll now start to move into the question and answer session. So I'm going to open up a question and answer bubble, and you guys should all be able to see that now, where you can go in and start entering your questions. I'll pause for just a minute or two while people can get their questions typed in there. And Mike, while we're waiting, if you could go and address this slide, Mike. There were some people that said they were unable to see. So if you could just address a little bit, what are the data layers that you used to get to this complete solution here, and what was kind of the positive ROI?
Sure, Scott. So we first started with multiple years of yield data, elevation, and some bare ground imagery to create the zones that were specifically targeted to each production area of the field. Those zones were then soil sampled with the polygon approach to get an accurate resolution of what's going on those in each of those zones. We then ran the soil insights tool to begin to understand how the nutrients were affecting yield on the farm, and ultimately how they were impacting yield. And that's where that set of curves came from that we showed a couple slides previous to that, which began to show us what the most limiting nutrient is in each zone and what the optimum soil test level should be across the farm. And then from there, we went into the variable rate fertilizer applications and determining what products are needed and where. Because boron was identified as one of the nutrients and something we hadn't typically been applying in the past, we then implemented the script process, script analysis tool to show the positive ROI from the boron application. So quite a bit of intensity going on this field using all the tools, but this is something we've been doing on our farm for the last 15 years. So it's not new to us. Out of the gate with a customer, I would say, as a starting point, just build some decent zones based off some yield and do some soil sampling out of the gate, see what the variability looks like and where the opportunities lie, and begin to make some changes from there. I see Tom Carlton, I believe, asked a question about lime on this farm being the probably most critical and then the first place to start. And I can't agree with that question more. Definitely the pH and the lime issue on this farm is critical. It's something we've been working on for the past couple of years. These results definitely show that it is one of the most limiting factors along with the boron. So a lime application was made, and it will continue to be made until we can amend that problem and get it fixed. Obviously, correcting pH first will make the other nutrients more available and have some greater success as we go. But now with these tools, we have a way to measure how these applications are affecting the overall fertility, how it's adjusting and then changing yield as we move forward, and showing, are we on the right track and are we getting a return from the products that we are spreading on the field.
Yeah, thanks, Mike. So we've got 3 questions so far, and please keep your questions going. You have answered the first question about addressing lime. I'd say the next question goes right back to your boron. The question is, since some people believe that the boron test is unreliable, how do we determine our boron levels, and can they be influenced by the different environment or soil moisture availability?
Sure. I mean, absolutely. That's a great question. And, that, I guess that all depends on the lab and testing practices and what the reliability is of that test. I think that just adds more grounds for doing research like this on the farm. I mean, whether or not the test is accurate or not, getting a 13 bushel increase from a 1.25 pound application of boron, to me, tells me that boron is deficient and I need to apply it to my field. If the result was the other way, then sure, absolutely. If it's not paying, then don't do it. I think, as the case is with a lot of soil sampling practices, if we get really critical and look at the actual number on the test itself, sure, there's some variability and there's some inaccuracy. But when we start looking at the trends and the general conclusions we can make, then I think we can all do a better job and be smarter. I can't get into an argument, and I don't have the knowledge to say what the optimum boron soil test level is on a test. But I can say that when you get below 1 part per million, you start to see a response of some sort. And when you get down to the 0.1 or 0.2, like we showed in this field, you're definitely going to see a response. I mean, you're getting to a very, very low level. So it all depends on your soil type, the parent soil material you have, and what nutrients you're going to get a response from or not. And, you know, if the soil test is telling you something, then do a trial. Do a test like this. Confirm to yourself, prove to yourself that it is the right direction to go in and I am getting a response and there's money to be made by doing it. If there's not, then don't bother. I mean, the point of this is to make our operations more money, and if for the ag retailers or agronomists on the call, to help our customers make more money. And that's the name of the game in this, is being more efficient and being more profitable.
Thanks, Mike. Great way to tie together how measuring your yield and actually what it does for you monetarily is more in line with what the numbers might say. Is it proven a positive ROI for you, either by increased value or decreased cost? Next question is, and I'll let you figure out how to address this, how do we incorporate soil health measurements into a methodology like this? What's some feedback on that?
Well, that's a great question. Yeah, the soil health topic's becoming more and more popular, and as it should be. I firmly believe the soil health piece is something that we can all do a better job on. Most of the research and data I've read around soil health all kind of stems back to that fertility question as well. I mean, and it makes sense when we think about it with that comment. You know, those really healthy soils on our farm are typically producing our highest yields and our best conditions for growth. So, you know, I think there's a lot of ways we can look at soil health, and we can look at ways to improve that. Soil testing is just one answer in that. Obviously, it gives us total nutrients available. I think the soil health topic really starts to dive into some of those other questions that aren't answered by the soil test. How do we start managing the microbes better? We'll do things like cover crops or green manures or things like that, start to help build those organic matters and levels up and start correcting some of those moisture issues and things like that we have on those tougher areas of the field. So, you know, this approach maybe isn't the silver bullet for soil health, but at the same time, I think we'll see some very, very strong trends. The work we've been doing with our partners, A&L Labs, around their soil health test, their soil vitellus test, has initially shown some really positive correlations between fertility levels and soil health. We also see a very strong correlation between NDVI imagery and yield. Obviously, for those in the room that have seen that correlation, it's strong. And you know, I would say there's greater than 90% correlation between, you know, those red areas you see on the screen in front of you now will also be the red areas on your NDVI image with poor crop health throughout the growing season, and they will also be the areas with the lowest soil health rating on a soil health test, and vice versa, obviously, for the green areas. So starting to tie all this back together, soil health is extremely important. That directly ties into our fertility levels, which ultimately directly ties into our plant growth, plant health, and overall yield and profitability at the end of the year. So work's being done on that front to start answering the question in a little more depth, but definitely the same zones will apply. And ultimately, at the end of the day, it's going to be how do we begin to manage those zones differently across the field to better improve that soil health aspect as well as control.
Yeah, thanks, Mike. We have about 10 minutes, and we're going to keep answering questions until we're about out of time. So we have 3 standing questions right now, and we'll push through these. The next one gets down into recommendations of, do we have a recommendation for applying gypsum? And I don't know, Mike, I'll let you or Carla go with this. We're not trying to necessarily give specific rates, but generally this concept of measuring what we're doing to get a positive ROI. So do you want to address that, Mike?
Sure. Yes, we can and have in the past made recommendations for gypsum. You know, it definitely is a decent product out there, especially on those soils where pH is, you know, not as big of a problem or is high enough, and calcium's the issue we're looking for. You know, it uses a little bit more the base saturation approach and percent calcium levels on the farm, trying to get to more of an optimum. So, you know, that's something that could be explored later, or you know, reach out and we can go through some of that. But obviously, lime is the cheapest and best source for amending calcium out of the gate. I would say gypsum becomes a very close second when pH is not the issue we're trying to fix. All depends on source and availability. There's some areas of the world where gypsum is very hard to get your hands on and very hard to come across. So yes, definitely ways to work with that gypsum question.
Thanks. We got 2 more questions so far, and both of these are dealing with boron, but they also directly apply into the methodology. So for the first question, using this example that we talked about today, is the cost of sampling and analytics included in the cost of treatment? And if so, how much of that $20.91 per acre is it? Like, so not to be specific because we don't know all the region's cost for collecting soil, can you broadly talk about how that breaks down for value of collecting the soil, doing the lab work, doing the analysis and the recommendations, and then how does that get back to the grower in some form of number?
Sure. So the boron example itself does not have the cost of the sampling or anything. The boron example is the cost of the prescription for the application of the boron, the cost of the application itself, and the cost of the product. So just everything related to that application itself versus the yield impact was all that was put into those numbers. So yes, you know, you could break out the soil sampling cost and associate it into those numbers as well if you choose. But there's a lot of other things that soil sampling is benefiting us as well. The lime application itself had a big enough impact in savings of lime and yield increase to pay for the soil sampling program in itself in entirety. This boron application, you know, when we're looking at the net profit of $40 an acre, also definitely covers the cost of the sampling and the application itself as well. And then, you know, the added benefits we get from the potassium, you know, phosphorus and magnesium applications as well. Harder to measure, obviously. Building soil is a long-term goal and a long-term plan, but having done it for multiple years, I mean, we see the benefits, and we don't spread fertilizer on any of our ground that isn't in a zero rate form. So the cost of doing that sampling is about $16 an acre for the collection and the lab results all in. So divided over our 4-year program, we're looking at about $4 an acre a year for the sampling. And then the prescription costs is, you know, anywhere from $3 to $5 an acre, depending on the amount in entirety for every time that the prescription gets applied to the field. So, you know, when we're talking $4, $5, $6 an acre a year for this level of data management, depending on your crop rotation and how many times you want to sample, I think there's excellent value there when you're starting to get into the 20 and 30 to $40 an acre return on investments, and the smarter decisions we have, and more importantly, the ability to apply this proven agronomy that we all know more accurately across the field.
Yeah, thanks, Mike. And as you're talking dollars, keep in mind that for this specific field, these numbers are in Canadian dollars. So if you're listening from the U.S., all pricing is different based on your region for soil collection or the lab that you may use. And for Canadian dollars, it's the U.S. dollar is about 0.75, 0.71. I'm sorry. So around a 30% difference in price there. But the scale remains generally the same with collection, lab work, and insights. The last question we have so far gets right back to the boron question is what is the highest application rate of boron that you're comfortable with if the field has less than 0.5 parts per million? So got a really discrepant field. What is your thoughts on jumpstarting it?
That's a good question, and I really wanted to put 2 pounds of boron on, and I got told don't go anywhere near it. I think we would probably be okay with that, but I'm very happy with the response we had with this product. 1.25 pounds just worked out for a nice equal 2 jugs across the 35-acre field, which is why it wound up being that 1.23 pounds to save costs and not have any extra product left over. I'm going to stick at that 1 to 1.5 pounds for the next little bit for this testing. And I'm going to try to do it for the next 5 years to see if we can start seeing any trends and increases in our soil testing values next time we go back and resample this field, and also to see if we continue to see a positive response to the treatment as years go by. I'm hoping we can build soil at this level, but I'm not sure we can. So short answer is I don't know, and I'm equally afraid of affecting crop in a negative way. So I think if we can see a positive response from an application at this level, it's economically feasible, and we just need to see now if it's a rate in which we can make a long-term effect. Well,
thanks, Mike. I appreciate the feedback and answering those questions. I appreciate everybody joining us today. I know we're in some challenging times, but we know it's number one, growing season or planting season, and a lot of prep is going on. Number two, we know everybody is having some challenges with physical isolation due to storefronts being closed and not able to have grower meetings. This is one way we're trying to help continue to educate, since we can't meet with growers. We can't get out into storefronts to continue to host these webinars. Everybody that attended, we appreciate it today. We will send you a link to this webinar once we get it uploaded. We'll send you a link so you can download, re-listen, and share if you'd like, and highly recommend please do so. If you do have some recommendations of things you would like us to talk about, by all means, please send those to us by email. And we actually did just get one more question, and we have enough time to answer that. For a $4 sampling and a $5 prescription, so just using rough numbers, what is the insights, the analytics cost? Mike?
Sure. So the soil insights, where you get the curves and those graphs that require the yield data analysis, along with a high enough resolution soil sampling that we can actually pull data from, you'd be looking at around $2 an acre, addition to the soil sampling application or soil sample analysis level that you did there. So relatively cheap information to get some very decent insights. And I would say that only needs to be done every time, like after every soil sampling. So every 3 to 4 years, depending on what your frequency is of crop rotation of sampling. So, as Carla mentioned in the presentation, grab that after the results come back, grab the year of yield that's most close to the soil sampling itself that hasn't had a fertilizer application, get those results done and get some of those insights for you. If you want to get the block approach with the analysis of the prescription, that's usually something that we need to add in ahead of time to the prescription. Obviously, we're not just going to do a general prescription without the blocks. We have to have the blocks implied before the application is done so that we can make sure that we know where everything is and they're strategically targeted. And that has that's where that $5 comes in. That would be built into that prescription. Typically, it's $3 an acre for a prescription, typically in our area. And then we add $2 for the insertion of the blocks and the analysis and all the data and the insights for you at the end of the season. So depending on which tool you pick, it's, you know, roughly an extra $1 or $2, you know, for each of those different services.
All right, thank you, Mike. With that, again, we thank you for your time, everybody. I know it's we really value your time and definitely value your questions. It helps us understand where the knowledge gaps are out in the industry and where we need to do better at our education efforts. We appreciate everybody joining us. And with that, we'll see you hopefully in a couple of weeks where we come out with another educational series. Thank you, everybody. Goodbye.